It began with a routine maintenance swap. A gas compressor valve was off the line for service, and its safety plug was temporarily replaced. When the night crew came on, the paperwork never caught up. They restarted the compressor, unaware that one safety valve was missing. Gas escaped, found an ignition source, and the platform lit up like a refinery in the clouds. The first explosion ruptured oil lines feeding nearby modules. The second turned the entire structure into a vertical torch. Helicopters couldn't get close. Crewmen crowded the accommodation block, waiting for an evacuation order that never came. The intercom and alarms had already failed. Firewalls collapsed, heat melted steel, and fuel lines continued to pump. When the blaze reached the pipeline risers, each one detonated in sequence. Out of more than 200 offshore workers, only a fraction made it into the freezing water. It was over in less than 2 hours. The investigation later found layer upon layer of preventable failure. Permits unsigned, isolation missing, communication gaps that turned one mistake into 167 funerals. From the smoke came an entirely new way of thinking about offshore safety. The safety case system, where every operator must prove a platform can survive its own worst day. But the price for that rule was paid on a burning rig in the North Sea. Late April, routine drilling on a high-pressure well. Mud readings start to jump, a sign that gas is entering the borehole. Instead of stopping, managers push to finish cementing before dawn. Minutes later, methane surges up the riser. It displaces the drilling mud, bursts onto the deck, and ignites. The first blast threw steel doors off their hinges. The second tore open the derrick. Fireballs shot 100 feet into the night. Emergency valves closed too slowly. The blowout preventer failed to shear the drill pipe, and the well went wild. Some crew members fought to close manifolds manually. Others scrambled to life rafts. Within hours, the rig was a floating inferno visible from shore. It burned for 2 days before capsizing and sinking into 5,000 feet of water. 11 people died in the explosion. Millions of barrels of oil followed them into the Gulf. The event became more than a disaster. It was a courtroom, an environmental reckoning, and a turning point in offshore regulation. Cement design, well control, contractor responsibility, everything was rewritten. But the scene that defined it all was simple: a single flicker of gas in a sealed pipe, missed in the glow of routine. A floating hotel for oil workers, anchored miles offshore, winds above 40 knots, waves rising fast. Then a metallic snap. One of the platform's 5 legs, joined by tubular braces, sheared after a fatigue crack propagated through a weld. The rig tilted, alarms sounded, and within minutes it had rolled 30 degrees. Inside, hundreds of men grabbed life vests and tried to reach the muster stations. Lighting failed. Escape ladders twisted out of reach as the structure continued to list. Only one lifeboat released cleanly, others jammed or flooded. When the last air pocket collapsed, the platform was upside down in the North Sea. Rescue helicopters circled debris through the night, but the freezing water allowed only minutes of survival. The inquiry found that a single crack, barely a few millimeters wide, had grown unseen until it triggered catastrophic failure. Design redundancy that should have saved the rig never existed. One leg's loss meant total collapse. Afterward, classification rules for semi-submersibles were rewritten worldwide. Every joint, every weld, every redundant buoyancy chamber had to prove its strength under storm load. From that wreck came the modern science of offshore structural fatigue. One joint taught engineers what an ocean can do. Far off Newfoundland, a winter cyclone hits with hurricane-force winds. The Ocean Ranger, a massive semi-submersible drilling rig, rides the waves at night while crews monitor ballast systems and keep the drill steady. A wave breaks higher than the control room windows. Seawater floods a ballast control panel, shorting out sensors and opening valves that were supposed to stay closed. The rig begins taking on water unevenly. When operators try to correct the list, the control indicators show false readings. More water floods the opposite pontoons. The tilt increases, cranes swing, pipes break. A distress call goes out at 1:30 a.m. By the time nearby vessels arrive, the lights are gone. The Ocean Ranger had capsized and disappeared beneath 250 feet of water. All 84 aboard were lost. The investigation showed how complex systems can kill through confusion, not explosion. gauges mislabeled, pumps reversed, crews trained for theory but not chaos. Weather, design, and human limits aligned in perfect sequence. New standards for watertight integrity, training, and ballast control design followed, but the phrase unsinkable rig died that night in the North Atlantic, a calm afternoon on India's western coast. Support vessel Samudra Suraksha approaches the Mumbai High North platform to transfer an injured worker. High seas make the maneuver difficult. A wave lifts the vessel, pushing it into one of the platform's gas risers, the high-pressure pipes carrying fuel to shore. The riser ruptures instantly, gas vents, ignites, and a fireball engulfs the deck. Flames spread through interconnected bridges to neighboring structures. Helicopters scramble, rescue boats fight heat and falling debris. Within minutes, the central production platform collapses. Dozens jump into the sea to escape the fire, clinging to life rings as debris rains around them. Several support ships burn or sink nearby before the blaze is contained. Post-incident reports showed that a simple procedural delay caused catastrophe. Marine traffic near offshore installations wasn't tightly regulated. Approach protocols existed but weren't enforced. The accident highlighted an overlooked hazard, collision, not explosion, as the spark for disaster. India's oil company rebuilt the platform, but the lesson stayed carved in steel. In confined offshore space, one wrong approach angle can ignite an entire field. Dawn on the Campos Basin, 80 miles off the Brazilian coast. A pressure surge in one of the Anchovy central wells ignites an explosion beneath the deck. Fire erupts through vent lines and cable trays. Alarms echo across the steel corridors. Crews scramble to lifeboats as gas flames curl around the derrick. One lifeboat lowers safely. The other jams halfway down, its winch cable twisted by heat. Dozens of men cling to the ropes, waiting for release. Then, the cable snaps. The craft plunges nearly 20 meters before hitting the sea, smashing on impact. 42 lives lost, many from that single mechanical failure. When the flames finally died, investigators discovered a failed safety valve, poor maintenance, and outdated evacuation gear. The tragedy rewrote Petrobras's offshore rules. Every platform afterward required enclosed lifeboats, heat-resistant launch rails, and dual escape systems. For Brazil's booming oil industry, it was the day safety stopped being a checklist and became survival design. A winter storm lashes Azerbaijan's offshore fields. Waves climb the height of buildings, hammering the Gunashli number 10 platform. At 10 p.m., one wave strikes hard enough to rupture a gas riser. Natural gas gushes from the break, hissing like a jet engine. Moments later, ignition. The explosion lights the Caspian horizon. Flames leap across multiple decks, fueled by high-pressure pipelines feeding the mainland. Power systems fail, communications cut out. Lifeboats swing wildly in the wind, impossible to lower safely. Crews crowd onto the upper deck, surrounded by fire on 3 sides and water on the 4th. Rescue helicopters circle for hours, but the storm makes winching impossible. Some men leap into the Black Sea, trusting waves overheat. 12 confirmed dead, many more missing, presumed lost. Official reports traced the sequence: corroded clamps, storm damage, and a delayed shut-off order. SOCAR, the national oil company, called it an act of nature. Investigators called it corrosion, left unchecked. The difference was academic. The fire burned for 5 days. That winter, Azerbaijan reinforced every gas riser in its offshore network with storm braces. The Caspian had claimed enough lessons already. Typhoon winds tear across the Bohai Gulf, where the Chinese semi-submersible rig Bohai 2 is drilling in shallow waters. The crew begins emergency ballast procedures to stabilize the platform, but the ventilation pump that keeps compartments dry fails under pressure. Water pours in faster than it can be expelled. Within minutes, the rig lists heavily to one side. Mayday signals are sent, but rescue vessels can't approach through the gale. The anchors drag, the rig drifts, and finally overturns. 4 people survive. 72 do not. Most were trapped inside flooded quarters when the rig inverted. The investigation concluded that the ballast system lacked redundancy. One pump failure meant total loss of control. Safety protocols had been modeled on calm weather operations, not typhoons. It became China's worst offshore accident and an early test for its growing oil program. From it came the nation's first marine engineering safety reforms. dual pump systems, emergency power generators, and storm evacuation thresholds. A single storm turned an industrial push into a decade of redesign. March 2024. Off the coast of Gabon, workers conduct routine well workover operations on a small fixed platform owned by Perenco. At 3 p.m., a pressure kick occurs during maintenance on a gas well. Gas vents unexpectedly, followed by a flash ignition. The fire erupts through the deck, spreading across the production line before emergency shut-in valves can close. Helicopters from nearby fields scramble, and support vessels activate water cannons. But the heat is too intense for approach. Within minutes, the structure collapses into the sea, leaving a burning slick on the surface. 5 workers killed, others injured. The company confirmed the event within hours. Reuters reported it as West Africa's deadliest oil accident in years. Early analysis pointed to an incomplete isolation of the well, a valve left open under residual pressure. Local authorities suspended operations across nearby fields for safety inspection. For most viewers, it was another headline. For the offshore community, it was proof that even in 2024, with all sensors and safety systems, the same equation still applied. One spark, one lapse, and metal gives way to flame. Technology evolves, but hydrocarbons don't forgive. In 2009, far out in the Timor Sea, the Montara platform was drilling quietly off Australia's northwest coast. A pressure test showed a minor leak, or so it seemed. What followed became one of the region's worst offshore disasters. Gas and oil burst from an unsealed casing, rising in a jet that hissed across the deck. The crew evacuated, leaving the wellhead spouting uncontrolled for 74 days. When repair teams finally returned in November, the gas ignited. The rig vanished in a wall of flame, burning for 2 days before it was sealed. No one died, but the fire destroyed the platform and spilled tens of thousands of barrels of crude into open water. Investigators later found missing safety barriers, faulty cement work, and supervisors who ignored warning signs. Australia rewrote its offshore rules after that. Independent well checks, third-party audits, no more blind trust in paperwork. The Montara fire proved you don't need an explosion to lose everything, just pressure, silence, and time. Between 2007 and 2018, official U.S. records list 33 offshore rig explosions in the Gulf of Mexico. They didn't make global news like Deepwater Horizon, but each left scars. Small fires, pressure kicks, helicopter crashes, and equipment failures. On average, 24 workers died every year during this period. Most incidents happened not on the drilling floor, but during transport and maintenance. A helicopter clipping a crane boom in fog. A flash fire during hot work welding near gas lines. A fall through open grating during a night shift. Each brief enough to vanish into statistics, each written into BSEE's incident database under dry headings like loss of containment or fatal fall. These weren't cataclysmic infernos. They were the slow bleed of complacency. Crews pushed through 12-hour shifts, safety drills skipped for schedule. Small leaks met sparks, and sparks met human error. The regulators responded with tighter inspections and electronic permit systems. But offshore culture changes slowly. Ask any Gulf veteran and they'll tell you the same. Disaster isn't always cinematic. Sometimes it's silent, a misread gauge, or a skipped checklist that never makes the news. The statistics prove it. Safety didn't collapse in a single blast. It eroded one shortcut at a time.